Hey guys, in section 20.10, we're going to learn about functional groups. Functional groups are combinations of atoms that you can stick onto a molecule to give the molecule certain properties. And it'll make more sense after looking at a few of them. It's also a way for chemists to categorize molecules. There are tens of millions of organic molecules, and it's nice to be able to lump some of them together into categories that are going to behave in a similar way. So the first one we look at are alcohols. In everyday language, alcohol is beer, wine, or spirits or something like that. But in chemistry, an alcohol is anything that has an oxygen and a hydrogen attached to it, right? So this oxygen-hydrogen combination, or hydroxide, if you remember all the way back to page 6 in chapter 4, is what makes something an alcohol. Now in this picture, R stands for the rest of the molecule, right? So this could be anything. This could be a benzene ring. This could be a carbon chain. This is anything at all. It's just that there's this OH coming off of it. And here's about the simplest example you can find. This is called methanol, right? Methanol is sometimes called wood alcohol. Back in the Prohibition era, when people were making their own alcohol, there was this idea that you could go blind or that homemade alcohol could be dangerous to you. And the reason is that methanol is pretty dangerous to people and animals. You really shouldn't be drinking methanol. Here's the OH that gives methanol its alcohol properties, right? So all this is, the carbon and 3 hydrogens, is a methyl group. So the methyl group is the R, and then the oxygen-hydrogen is what makes this molecule an alcohol. So the functional group in this case is the oxygen and hydrogen. Let's take a look at another example. You've maybe heard of ether before. In chemistry, an ether is an oxygen that has a single bond to some other piece. This we'll take a look at it. On the right side you can see an example. And then this R is just a different piece. Now the prime means that these two pieces don't have to be the same. Here's an example of where they are the same, but they don't necessarily have to be the same. But what they do need to have is this oxygen right in the middle connected to two different pieces, right? That's the defining feature of an ether. So the functional group is the oxygen with the two bonds coming off of it. You can see the R group on the left side has 2 carbons. That makes it an ethyl. The R prime group on the opposite side, in this case, also happens to be an ethyl. So it has a nice symmetry to it. But this is an ether. Again, the groups on the right and the left side don't have to be the same. Ketones might be a brand new word. You can find ketones in Runnings, for example, or maybe even Walmart if you go to their. Ketones are often used to maybe as solvents. And so if you go to the section where you'd find mineral spirits and things like that, you could find ketones. Ketones have to have this carbon double bonded to an oxygen. Here's the carbon double bonded to the oxygen. And then the carbon has to make single bonds on the right and on the left, where again, R is one group. R prime can be the same, but it can also be a different group. So this piece right here is the functional group, the carbon, the 2 double bonds, the oxygen, this bond, and this bond. This is the functional group for a ketone. Now over here we have a single methyl. That's the R group. Over here we have a single ethyl. That's the R prime group. This is a ketone. Aldehydes might be brand new to you. If you've taken a biology class, you may have dissected animals that were injected with formaldehyde, although I'm not sure if that's still used anymore. Aldehydes are fairly similar to ketones. There's only one difference. This point right here, this tip, represents a carbon atom. So there's the carbon. Just like in the ketones, it's double bonded to an oxygen. Double bonded to an oxygen. Just like in a ketone, there's an R group on one side. So in this case, we have a methyl group. And over here is a this is the difference right here, isn't it? In a ketone, this was another R group. In an aldehyde, this is always going to be hydrogen. Here's the hydrogen. And so this is what you're looking for when you identify aldehydes. This carbon double bonded to oxygen, single bonded to hydrogen. What this means is that this combination of oxygen, carbon, and hydrogen, it has to be on the end of the molecule, right? You can't bond anything to this hydrogen. It doesn't have any bonds left. You can't bond anything to this oxygen. It doesn't have any bonds left. And you can't bond anything else to this carbon because it doesn't have any bonds left. So this always represents the end of a molecule. Now you can stick anything you want on this side, but aldehydes always have this right on the end. That's different from a ketone. In a ketone, the functional group is generally in the middle. In fact, it's always in the middle, right? In an aldehyde, the functional group is always on one end. Now you'll notice that the ketones and the aldehydes had one thing in common, and that is this carbonyl group. They both have a carbon double bonded to an oxygen. The difference is that in a ketone, you put a substituent on there, you put an R group on there. In an aldehyde, you just slap a hydrogen on there. So here's the aldehyde on the bottom. You can see that the functional group has to come on the end of the molecule. You've got this long chain coming off the other side. And then here's the ketone, where you've got something on either side of it. And the result of that is that the properties of ketones are different from the properties of aldehydes. I'm not going to go into the details here, but you may have heard of ketones in the context of biology and medicine and even health, and ketone bodies that are formed by our liver, and ketosis, or sometimes in the context of diets, people talk about a ketone diet. That's a bit beyond our scope, but that's another context where you'd hear about ketones. There are many of these functional groups. We're only going to learn about two more of them. Here you can see another functional group that uses this carbonyl group. The carbon double bonded to the oxygen. It's got the R group on one side. That's identical to a ketone. It's identical to an aldehyde. Here's where the difference comes in. There has to be an oxygen attached to an R group on one end. And so here's an example of an ester. You've got the carbonyl group right here, carbon double bonded to an oxygen. You've got one R group coming off here on one side of it. This is a methyl group. But here's the oxygen. You say, Cato, that looks a lot like an ether, right? There's the ether. It's not, though. It's not, because it's got this carbonyl group, and that's the difference. That's the reason this is not an ether. And then here's the R prime, right? This has 4 carbons. This would be a butyl group. Esters tend to be longer because you've got this whole piece. Here's the functional group right here. If I were to give you one and say, identify the functional group, this is the piece you're looking for. Here's one R group. This is the shortest possible one. Could be much longer. And then here's a fairly substantial R prime right over here. Esters are often associated with smells. In fact, this video is being formed or recorded in the spring of 2020, so we're all on quarantine. But if you're watching this in a year when we're not on quarantine, we'll be doing a lab in which you'll make esters and you'll smell them, and they have some very familiar and usually pleasant odors. The final functional group we're going to take a look at is called carboxylic acids. And this is the most maybe involved one. It's a little bit similar to the ester. You get the carbon double bond to the oxygen, so there's the carbonyl. You get the R group up on the left side, just like we had in an ester. You get the oxygen, just like we did in an ester. But the difference is that instead of having an R prime, there's a hydrogen, right? So here's the carbon double bonded to oxygen with an R group and an oxygen. Carbon double bonded to oxygen with an R group and an oxygen, right? The only difference is that now we stick hydrogen right here. Just as in the case of an aldehyde, having this hydrogen meant that this piece, this functional group, always had to come at the end of a molecule. That's going to be exactly the same for a carboxylic acid. This piece always has to come at the end of a molecule. In this case, we have just a methyl group as our R group coming off the end. Carboxylic acids come up quite a bit in biology, but again, that takes us beyond the scope of this class. But you might encounter these if you take a biology class. So these are the functional groups we'll be learning about. There are many more, but we're going to focus on these. What is it? 2, 4, 6, 7, which is probably sufficient for the time being. And once you understand how functional groups work, picking up more of them isn't too much additional work.